we'll be drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher.
Education, Junior Maths Olympiad holds equation of a circle, delegating and manipulating equation of a circle. Now a circle has a radius and it has a point, and the point has two coordinates, minus g minus f, or h and k, and at the circumference point where the radius touches circumference, point x and y. Now if it is that of diameter, you can see diameter, two radii make a diameter. At one end, point A, S1, Y1, at the other end, point B, S2, Y2. Then now, the diameter divide a circle into a semicircle. Now, if you project this point and this point to any point, anywhere on the circumference, it gives you a right angle triangle. Just like this side is also a semicircle. If I should project this point here, and I project it here, provided this place is diameter, the angle here is 90 degrees. So that means we have a right angle triangle, we have another right angle triangle. Please take note of that. Now, so if you have 2 points, and this is the radius or distance, okay, to establish the length of this is that we will take, let's say this is h now k, and this is x, y. So the radius, this, if you project this like this, you have a right angle triangle. So it means change along the y-axis over change along the x-axis. So if you apply Pythagoras theorem, okay, if you apply Pythagoras theorem, you have, look at it here, please put it there. You have r squared delta y squared plus delta x squared. Hypotenuse side equals the square of this, square of this. Now, delta y, this is y, that will be this minus this, or y minus this. So we have r squared with the y minus k squared, the y component, plus the x component, x minus h squared, s minus h squared. Okay, that's how we arrive at this. So that is just to tell you how I arrive at some of the things that I wrote here. So here, if you use this, you have the radius of the circle. Okay, now if you expand this, or if you use the other one, minus d minus f, okay, you have this with a constant, one that does not have x and y. If you further simplify this properly, the constant, if you establish this in completing the square method, half of this is g, then g squared, take to the other side. Half of 2f is f squared, take to the other side. The constant, when it is plus, it turns to minus. If it is minus, it turns to plus. Okay? So this one now equals to this r squared. Okay, so r squared equals g squared plus f squared. So what aggregate gradient? I just told you the other time. Gradient m is change in y over change in what? X. So you find the gradient between this point and this, which is this, and between this point and this, which is this. So the two gradients give us minus 1, provided you are given the two ends of the diameter, A and B. You project it, the two projections meet at 90 degrees, and there's a relationship for that. Gradient 1 times gradient 2 equals to minus 1. Alright, so that is all that I need to explain there. Now, take note of that. You can have a review of that at your convenience. Now, we want to see how to get this problem solved. Now, there are some characteristics of equation of a circle. Sorry. So we have x squared plus y squared minus 4x plus 2y minus a constant equal to 0. Now, this x squared must have a coefficient of 1. So this one conforms to equation of a circle. Or it must be something like this, 2x squared plus 2y squared minus 4x plus 2y minus 3 equal to 0. The coefficient is not necessary that it should be 1, but where it is not equal to 1, it must be the same thing. The coefficient must be the same thing. If it is not the same thing, it's not acceptable. But when you want to use it to find the center or the radius, then you must divide this by 2, both sides by 2. You divide both sides by 2 all round. So at this place we end up being 1 because it must be 1, 1. That is true. Thirdly, if you have 8x squared plus 8y squared, which is correct because the coefficient of x squared and y squared will be the same thing, one of the attributes of the equation of a circle. Then we have this one minus. Now look at this: 8xy plus 7x minus 8y equals to 0. No constant is permissible. But this one, in the equation of a circle, sy must not exist. So this one does not hold. So there's something like sy. By the time you open up those equations I clean up. So these are the attributes. So now let's see this in using this one now to solve the problem here. Let's start with number 3. I want to start with number 3. Let's eliminate sum. Now, the equation of a circle is given by 5x squared plus 3y squared minus 8x plus 10y minus 11 equals to 0. Now, if you look at this, the coefficients are not uniform. It's not 1. One is 5, the other one is 3. Find the radius. This equation does not exist for equation of a circle. So this answer is impossible. Don't even waste your time. Impossible to solve. When you see the coefficient of x squared and y squared not being the same, not being the same thing, or not being equal to 1, it's not possible to do it. So impossible to solve. Let's look at question number 3. The equation of a circle is given as x squared plus y squared minus 3xy plus x minus y equal to 0. This exists. But look at this. 3xy does not exist in the equation of a circle. So finding the radius will be impossible. So this is the answer. So we have knocked off those two. Now let's now come back to this one. Number 1. The equation of a circle is given by x squared plus y squared minus 4x plus 2y minus 3 equal to 0. Now, you will take this constant to the other side. Now, this one, the equation, the center is minus g minus f. Okay? So, if you look at this one now, half of this, you express it completely the square. Half of the coefficient of x is half of minus 4, that's minus 2. Half of this one, coefficient of y, 2 is 1. You put 1 there, plus 1. Now, if you compare this to this, you can see that minus g is equal to minus 2. That means g is equal to 2. Then minus f is equal to 1. It means f is equal to what? Minus 1. So by the time you do the completely the square and you push to the other side, you will get your r squared being equal to g squared plus f squared plus the constant, plus or minus the constant. But in this case, the constant is minus a, it's turned to plus c. So r squared will be 2 squared plus 1 squared plus the constant 3. So r squared will be 4 plus 1 plus 3. R squared will be 8. So r now will be square root of 8. Remember that 8 is 2 times 4 square root. This 4 will come out as 2. Then we have this. So that is the radius. Why is it? Okay, that's the radius. Why the center? If they ask you for the center is simply g is simply this, the positive 2, minus 1. That's the center. The center of the circle. But they didn't ask for that. Okay? Now, that is that. I can clean all this now because we have addressed that. So now, find the center and the radius of the following circles. Like I told you, the center is minus g minus half. Now, this one, you have to verify that the coefficient is 1. That is the first step, yes. So, coefficient of, what is half of this one? That is 2. So, you put 2 there, comma. Half of minus 6, that's minus 3. Now, if you compare this to this, you get the center. The center equals to minus g equals to 2. That means g will be minus 2. Minus f equals to minus 3. That means f will be 3 plus 3. Minus will cancel minus. That's the center. And the radius. Now, radius, you know that r squared is equals to g squared. This is g minus f now. If you square minus g, the minus will disappear. You square minus f, minus will disappear. So plus f squared plus c. But in this case, the c is plus a, so it will turn to minus a. By the time you take it to the other side. So you know your value now. You know your g to be this. You know your f to be this. So you can go ahead to compute your radius of the circle. That will be minus 2 squared plus 3 squared minus 12. So r squared will be 4 plus 9 minus 12. R squared will be 13 minus 12. So r squared will be 1. So r will be square root of 1, which is 1. So we have gotten the center. The center is this. The radius is this. Now, the last one there, before I look at 2 other questions here, before I add up this. Now, this one, 2x squared plus 2y squared, yes, this conforms to equation of a circle because the coefficient of x squared and y squared is uniform. So, the first step is that you divide 2 because you must make it 1. 2x squared over 2 plus 2y squared over 2 plus x over 2 plus y over 2 equals to, you notice that there is no constant here. So the constant c here is 0. Take note of that. So this gives us x squared plus y squared plus half x plus half y equals to 0. C constant does not exist. Okay. Now, equation at the center we have minus g minus f. Okay, now half of the coefficient of x, half of half, that's 1 over 4. Half of the coefficient of y, half of y, half of half, that is also 1 over 4. Okay, now that means our g is minus 1 over 4. Compare this with this, our f is minus 1 over 4. So the center of the circle is this, minus 1 over 4, minus 1 over 4. Now, to get the radius is r squared equals to g squared plus f squared plus or minus c equals to 0. Okay, so r squared now give us, what is this? That is minus 1 over 4 plus minus squared plus minus 1 over 4 squared plus 0 because the constant does not exist there. Okay, so r squared will be 1 over 16 plus 1 over 16. Okay, let me clean this one here. Let me complete it here. Okay, now this gives us plus that 0 is at the surface. We have r squared is equal to, find the LCM, 16. 1 plus 1, so r squared will be 2 over 16. Find the square root of both sides. That is square root of this 2 over 16. Square root of 2, you leave it there in such form. Square root of 16, that is 4. So the radius is with 2 over 4. While the center is this, minus 1 over 4 minus 1 over 4 because they ask you. Now, there are 2 other questions I would love to clarify. What if you are given the equation, given the center and radius? We look at that.
Down the river we drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over we down. We're getting a fire.